Hello guys, here is 8xplorers. Today we're going to introduce our team and also our unique ROV robot to you guys. So today our presentation will be divided as 5 parts. The first part, the team introduction. The second part, the ROV robot introduction. The third part, our project goals. The fourth part, our design overview. And the fifth part, our reflection and next steps. So here is our team, and my name is Cheat. I'm the team video planner.
And my name is Austin. I'm the designer in our team.
My name is Bernice and I'm in charge of the technical design report.
I'm Flora. My work is building the ROV.
And I'm Hinson. I'm in charge of the report.
I'm Leon and I'm also in charge of building ROV.
I'm Rosianna and I'm in charge in the report.
I'm Vienna and I'm in charge of building the ROV.
So now let me introduce our team to you guys. At first, I want to tell you why we named us Explorers. It is because we are always interested and also curious about new things. And also we have 8 members in our group, so we named ourselves Explorers. So these are the advantages and disadvantages in our group. At first, we neatly divided our work. It means that everyone has a clear role and clear instruction in their role. The second is everyone has their own advantages. It means that we place our members well, and so that they can be a better them and also to make a better us. The third point is a little bit disadvantages. It is because it is the first time for us to join this competition. There are a lot of silly mistakes that we make. We're a lack of experience and a lack of time. So we hope that we can do it better next time. Now let's have Leon for our ROV introduction.
And here is our ROV. And our ROV is a Seaperch. A Seaperch is relatively a simple ROV that can be made of some simple materials and mainly included PVC pipes. And apart from that, we have got the 4-stage float tube for balancing the buoyancy, some cable types to fasten the body parts, and 3 thrusters over here for providing the power. Our ROV project has a unique design which using the newest technique like 3D printing. We choose to use 3D printer because we think it can hold the motor better than using cable ties and non-slip mats. And here is the process that how we hold the motor. And apart from that, let's talk about the float tubes design. We used to have 2 integrated float tubes on top, but during our test we found that it's not good for the buoyancy balance, so we turned it into 4. So let's welcome Bernice.
So, you noticed that we added some float tubes, which is in charge for the buoyancy. But when we first tested, we found out that even if we use some cable ties to wrap around the float tubes, it still moves around really easily when we're doing the task. So we decided to cut all the float tubes and then add some non-slip mats underneath it in order to prevent it from moving so frequently. And if you have noticed, we have a cross joint here in front. It was supposed to be a T-pipe, but during the first test when we tried to open the door, we found out that the T-pipe only has 2 angles, and as if we change it to the cross joint, we're able to open the door even if the ROV is flipped around. And yeah, this is the end of the design approach. Next would be
As you can see, these are our results. In crossing the hoops, we crossed it in 4 minutes and 3 seconds in the first attempt, and we crossed it in 4 minutes and 11 seconds in the second attempt. And by opening the door, we crossed it in 3 minutes and 27 seconds in the first attempt. And the second attempt, we crossed it in 2 minutes and 56 seconds. We have some special features. Our ROV is quite light and speedy. and also neat and tidy, and we tied the cables. neatly, so that it is very neat, and we connected the wire very neatly and securely, so it's easily controlled, and it could ride smoothly in the water. In the near future, we hope to improve this machine and add more functions. And we also can do some experiments to test the internal computer, and we strive to the best.
Now I have a little conclusion and also an overview of our design. So it must be light and also speedy. It must also be secure and also safe. Also, we add some 3D printing skills in our robot, like this, to stabilize our motor. So now let's have our reflection time. So, let me start first. Throughout the Seaperch competition, we were assigned to lots of challenging tasks. We spent hours and hours trying to solve our problem. We learned a lot from these exciting challenges.
During the process of preparing for this competition, I understand the importance of learning how to separate our workload, and this project let us realize that separating our workload can reduce each teammate's stress.
And I think that have a chance to participate in these competitions. I learned a lot of engineering skills, and I felt very lucky to be a part of the team. Preparing for this competition is a best memories in my high school life.
So all in all, now we'll talk about the next steps of what we're going to do. So getting a chance to participate in the International Seaperch Challenge gave us an opportunity to learn more about engineering. And we also got to develop a special bond with each teammate during when we're preparing for this competition. And we hope that the skills we learned in this competition will guide us to our dream job during university and help us understand ourselves more. Okay.
1, 2, 3.
Thank you.